All right, I should be recording now. And this is the Doppler display unit. And it's getting kind of late in the day. I don't have the lighting I'd like to have, but I've got a flashlight. If I have to, I'll use that. This is the front panel of the display unit. Speaker grill on the left. Combination of Polaris and numeric display in the center. This is a locking drawer that holds the two ICOM R6 receivers that are used with the DF. And let me pause the video here briefly and see if I can find the keys for the drawer. Okay, here's the keys. I've ordered 4 more, and I'll get those before I ship this thing. And I decided I better lock these things up because, number one, they could be pretty tempting for somebody who wants to play with this stuff. And number two, even if they didn't want to steal it, they might want to play with the controls and, you know, mess things up. So I decided it was probably best to keep it away from them and under lock and key. So there's the key inserted. I'm going to rotate it 90 degrees. And pull it down. I left the user's manual inside because you'll need this information to change any of the control settings if that's why you're opening it up. And pull this up a little bit. Actually, let me get this off. That's what it looks like inside. Okay. There's some ICOM charger stands at the back of the box here to provide mounts for these radios. The chargers have been defeated; they don't work, but they do provide a mechanical mounting for them to hold these things. The radio on the on the left-hand side is the radio direction finder. It says that on the cable. Label on the other cable says monitor, so that's for the monitor audio. And these things can just be pulled out of the charger rack. That's what it looks like. And then you can, there's enough slack so you can pull it all the way out and operate the controls. Change anything you want, frequency, volume controls, Welch setting, stuff like that. And then put them back in. Okay, same for this. And let's see, what else can I say there? Anyway, I'm going to leave the manual in here. Oops. Once again, I'll close this up. Now, regarding this lock, you can remove the key if the door is locked. You can also remove it if the door is open. But if it's somewhere in between, the lock will not allow you to remove it. The key becomes captive. So, if you're holding the key, that means that this door is either locked or it's open. Okay? But that means you did not leave the key somewhere else, which should be pretty obvious if you're looking at it. But I just wanted to point that out. Okay. The panel controls. I'm going to hook this up for a few minutes and show it off also. There's a 3-position toggle switch here for the radio direction finder. The bottom switch position and the middle position are stationary. The top one is spring-loaded, and the top one is spring-loaded because that's a test position. You don't want to leave it in the test position. In the bottom position, the DF is on, and in the middle position, the DF is off. in the spring load position, the test signal is generated, and you can use that to adjust the calibration. With the DF on, okay, well, let me point one other thing out. There's another switch here for the speaker select. You can switch the speaker between either the monitor receiver or the RDF receiver. Okay, and that's important because if you want to set the squelch on the RDF receiver, you got to listen to the audio. So you can do that with this. Here's the volume control for the speaker, and got a pretty healthy amount of volume on that thing, probably more than you'd want to leave it up too high. If you turn the RDF off, that will not turn off the display, so be aware of that. Okay. If you turn the RDF off, one thing it will do is it will turn off the whine in the audio, which will make it easier for you to understand what the person is saying if you want to hear that. And also make it easier to maybe set the squelch control if you're operating with the controls in the radio. So with this in the on position, you'll hear the DF whine, or you should, when there's a signal on the channel. With the DF off, you should not hear the whine when there's a signal on the channel. When the filter, with the switch pressed up temporary, that will invoke the test function, which will cause the one of the antenna signals to be fed back into the DF, and it'll give you a bearing at 000, unless you've got some other value set into the calibration buttons on the back of the panel. And I'll point those out in a few minutes. So those are the controls. Okay, and that's the speaker. The 19-inch rack mount, 3 units wide, 3 units high, which would be 5.25 inches. This will run off of anything from 15 to 35 volts DC for the emergency power backup, or anywhere from about 90 to about 250 volts AC, about 45 to 60 to 70 hertz or so. The power supply is completely universal and fully agile. It'll figure out what's available for it, and it'll use it. And I did the tests with I did the final acceptance tests with the AC power supply, running off of 110 volts, and it worked fine. Didn't have to change any straps or anything. The power supply figured it out. Didn't have any problems. And that same power supply will deal with 230 volts perfectly well. I wasn't able to test that here, but I believe it. That's one of the reasons I selected this power supply. So that's it. I want to keep the controls as simple as possible. I wanted to lock away the receivers so that people couldn't play with them and screw up the frequency or the mode of operation or something like that, and you know, and then not tell anybody about it. So this is locked up, and for that, I'll go look at the back panel. Okay, this is, I think, probably 8 inches. Let me see. Yeah, it looks like about 8.5 inches to the front panel. This is about 16 5/8, and I know it's 5.25 inches. Height. Okay. We're looking at the rear panel. Okay. Here's the input for the AC power cord. I'm going to provide the power cord with this. It's a European style for 220 volts. That's the type of cord that's commonly used in Nigeria, if I believe what I'm told on the internet. So that should work fine for you. This is a AC power on and off, but it's also a 1 ampere circuit breaker. So if you lose AC power, you might check this to make sure that it's turned on. There's a little LED in there which lights up when the power is turned on, assuming power is available. I accidentally installed this thing upside down, and it's not really designed to be removed, so I had to leave it like that. The power is actually on when the lower part of the rocker switch is flush. So right now the switch is on. Okay, DC power input for emergency power. Anything from about 15 to 35 volts will work. I'm going to remove this battery clip. This is only on it so that I can test it here. Polarity is indicated below. Above that are three digital push button switches to set the DF calibration. And I'll talk more about those in a minute. Okay, next to it, up here we have the connections for the RDF radio, the Doppler radio. Here's for the antenna. Here's for the antenna control cable. These have to both go up to the DF antenna. Here's connections for the monitor radio. That has a separate antenna. Here's the audio output. This is the 3.5 millimeter audio jack. It only has audio on the tip of connection, which in my computer is the left channel on the earphones. So it's only putting on one channel. If the computer that this is going to, I don't know if you can deal with that or not. Otherwise, you can make an adapter cable of some sort to get it into both channels if you really want it. Once again, here's the nameplate describing what this is. I didn't give it a serial number. I just called this AirDopp 2.0. There's some contact information to reach me on this placard. These placards are actually mil-spec placards. They should never fade. They should be resistant to abrasion and chemical problems. They won't scratch out or wash out, or they're very durable. They'll last for years. So, and that's what all these labels are. Okay, to the right of that, we've got four COM ports, RS-232 DB9 female connectors. All four of these have been tested. All four of them put out the direction finder data at 4800 baud. And you can use these to drive an IBM PC and to display the DF data. I've got the display programs are on my website for free. You can download them and use them. And Soji is familiar with those. And so that's what this is for. These are four independent COM ports. They all put out exactly the same data, and I just provided four of them in case you wanted to have 2 or 3 separate displays in the control tower. So that's what those are for. They only put out signals when there's a signal on the channel and the DF is indicating a bearing. They do not put out signals at any other time. So if you're looking for data there, you won't see it unless there's a signal on the channel and unless the DF is turned on and watching it. So there they are. Okay, back to the RDF calibration. When the antenna is first installed, there's no telling which direction it's going to be pointing. So you need to do a test. You need to generate a signal coming from a specific direction that you know is correct, and know what the number is for that bearing. And then, using the test feature on the toggle switch on the other side of the radio here, or the other side of the DF unit, you can operate these switches in order to get the indicator to show the proper bearing. This thing has got enough authority to rotate the display a complete 1.5 turns, so you can basically point the antenna in any direction you want, and then you can electrically rotate it with these switches. Now these switches go from 000 to 999. The switches on the top are labeled plus, which means when you press them the numbers go up, like I'm doing now. Okay. And the other buttons will take the number down. Okay. Now these numbers correspond to the full range of this corresponds to 512 degrees, which is about 1.5 turns on the display. So changing one step on this digit will change the display reading by 51.2 degrees. That's 512 divided by 10. Changing this digit by 1 will change the indicated bearing by 5.12 degrees. That's 512 divided by 100. And changing one changing this digit by 1 will change the display bearing by 0.512 degrees. That's 512 divided by 1,000. And 3 digits will allow you to go from 000 to 999. That's 1,000. So that's pretty quick, but you know, if you didn't catch anything, you know, just rewind the tape or rewind the video and play it again. And Soji's probably familiar with some of this stuff, or most of this stuff, pretty well. This is all very similar to the first DF, except I've added a few features. And for that, I think I'm going to plug this thing in. Actually, let me stop the video here for a second and restart. Okay, it should have started again by now, so we're back to recording. Okay. I'm going to plug this into the DC input. Well, actually, let me see what voltage is putting out first. 15.9 volts. Okay. So plug this in. I'm going to turn this on. And here we go. Now it's going to go through self-test. And there you go. There's that. Now I'm going to open this up. Pull out the audio radio. There's a button on the side to temporarily open the squelch. So when I press this button down, you hear the squelch is working. Right now I've got the RDF radio selected as the speaker. I switch it to this one, then the other one will be the one that's driving the speaker. The volume setting on this one is considerably lower. You can tell that. So right now this is set for weather 1, which is 162.55 megahertz here in California, and it's where I am. And I think that's pretty much universally true all around the world. I don't know what it is in your area. There's about 4 or 5 weather channels. But this is right now set for 162.55 megahertz. You can set it to other things if you want. And all the information on how to do that is going to be in this book. So this is set for 127.000. Shine a light on it and make that a little more obvious. Okay. So, and I'm going to leave it on that. The channel spacing right now on this one is set for 8.33 kilohertz. It's set for airband. The mode is set for narrowband FM, which is what you need to run the Doppler. And I think I got the volume is set to a level that will reliably trigger the Doppler circuits. So that, I'll just slip this back in its pouch there. Close this up. Okay. If you have a power outage, this thing will automatically switch from the AC power source to the DC power source so fast that you'll never even know that it's switched. Okay, it's diode switched. So you don't have to worry about that. I've also done experiments on these ICOM R6 radios, and even if you turn the power off completely, when you reapply the power, it will go back to whatever state it was in when it was shut off. So right now the radios are turned on, and if I turn the power completely off and turn it back on, you'll see that the radios also turn back on. And here we are, weather 01. I'll do it again. Power is off. Turn the power back on. And the radio came back on. And that's true for the other one as well. I was really pleased to see that happen because I was worried that I might have to build up some kind of a circuit to automatically turn these things on, and it turns out I didn't have to. So, there's that. And now I'm going to do the self-test. Okay, here's the audio switch. Right now it's in the off position. Okay. Actually, I guess I could demonstrate. Well, no, I can't demonstrate the DF line without an antenna connection. I'm going to turn this on. Okay. This is putting out a very, very strong signal right now. It's so strong that even without an antenna, it's almost strong enough to open up and operate the radio. Okay. So that is set on 127 megahertz. And as you can see, the receiver is hearing the signal. I'm going to turn that off. I'm going to move this up to 162.55. On again. Okay. So there's 162.55. Go back down to 127. And there's that. Now, I push this switch up to the test position. You can see that the display is going to indicate 0 degrees, or actually 359. Okay, now I'm going to operate some of these calibration buttons on the back. First, this is the hundredths digit, so if I click this, it's going to change the reading by 51 degrees. And you can see it did. I'll push it again. There's another 51 degrees. Push it again. Another 51 degrees. 203, 354, 305, 356, 047, 099, and that's it. Then it was switched back over, it rolled over to 0. So now I'm going to press the X10 digit, which should change it by 5.12 degrees. Okay, so there's 4. Okay, do it again. 9, 14, 19, 14, 19, 24, 29. And then back to 0, rolled over to 0. Now the last digit only goes half a degree per step. So, okay, here's, right now the digit is on 0. I'll do 0. Here's 1. Here's 2. Here's 3. Here's 4. Here's 5. Here's 6. Here's 7. Here's 8. Here's 9. And 0 again. So that's it. That's what the calibration buttons do. And that's what the test button allows you to do. That way, if you know how much the antenna correction needs to be, but there's no signals on the channel for you to drive the display, the test feature will allow you to generate a display without any signals on the channel. And you can enter the correct amount of correction with the push buttons on the back panel. So I'll release the button now, and it'll hold the reading for a second or two, and then go back into hunting mode. And that's essentially it. That's the display. And with that, I think I'll call this video quits. And thanks for your attention. Adios.